Okay, so we'll start. Right, we'll start the procedure. First of all, we are placing a table, right, or using a table at least 2 meters length of the table. Then placing, we stand using the non-focal length double convex lens. So lens I am placing on the table here. Right, lens is placed. Then measure the object distance as you decided. So here I am decided that object position is 60 centimeters from the pole. So that place I am using the object. Here object is lighted candle. It's a flame act as object. That flame must be above the principal axis. Right. Then I need to observe the image. I need to observe the image here. So here image may be virtual or real, maybe virtual or real. So here if virtual image is formed, directly we can see that virtual image on lens, right? If it is real, you need screen. What is your screen here? White sheet paper. So use white sheet paper after noticing the object distance here as 60 centimeters. Then first observe the type of image. First move the screen opposite side to the object. Another lens. So here lens is using here convex lenses. So here opposite side of the object I used the paper. And then move from the lens. Move from the lens. Did you see any image on the screen? Did you see any image on the screen? Is it visible? Image is obtained or not? Yes. Where we obtained image? On the screen or on the surface of lens? On the screen. So what type of image is this? Real image, right? Then what is the distance here? The distance we need to measure. So I'm moving the scale, right? I'm moving the scale. Where it will be? Exactly at 60 centimeters. Exactly at 60 centimeters. So notice that value in the table. Then change the position. Now I'm placing the stand same place, but the distance of the object is 50 centimeters. So at 50, I placed the object here. Then the same thing, that same process, same steps will be followed. It is above the principal axis, compulsory. Then notice that object distance in the table, 50 centimeters. Move your screen opposite side to the object. Slowly move it. Did you see any image? Yes, image is obtained. Then the size of image is larger than the object. Enlarged image. Enlarged image. Then what about the distance? The distance you need to measure. What will be the distance here? It is nearly 75 centimeters. Noticed in the table. Then change the position of object again here. Right? Now I placed the object at 40 centimeters. 60, 50, 40. So now the object is placed at 40 centimeter distance. Then same steps would be followed by you moving the screen away from the lens here. Then slowly move your screen. Again, the image is formed. Again, the image is formed. Then measure the image distance here. Place your scale here. Then what will be the distance here? It is approximately 120. So note down in the table. Completed. Then change the position to the 30 centimeters. Place the object at 30 centimeter distance from the lens. So candle, lighted candle is placed. Change it to 30 centimeters above the principal axis. That flame observed. Okay. Note down the value in the table. That is 30 centimeters. Then move your screen here. Move your screen slowly away from the lens. Any image is obtained. Look at that. Any image is obtained on the screen? Give me your response. Did you see any image? No image, right? So no image is obtained for any distance from the lens. The screen placed any distance from the lens, no image. So in this case, what to do? We have to observe on the surface of lens, right? From this direction. Did you see any image on the screen? Sorry, on the surface. So here in this case, we did not see any image on the screen or on the lens. So no image on the screen and no image on the lens. So here let us try to see the image may formed on the surface of a lens same side where we kept the object. So no image. So what we can write here? We cannot see image on the surface of lens and on the surface of screen. So in this case, we will note down the distance at infinity, at infinity distance, right? Then change the position of object 30 to 20 centimeters. Object brought to 20 centimeter distance from the lens. Then again, move your screen from opposite side of the object, another side of the lens. Then note down the value here, notice it. Then move your screen away from the lens slowly. Did you see any image? Again, no image formed. Again, no image formed. Then what to do? We need to observe for that image on the lens. So let us try to see the image may formed on the lens surface, same side where we kept the object. So here just you need to observe another side. We can see the image on the surface of lens here in this case. So that image will be on the surface. Now how the image is shown on the lens? Exactly facing upward. So upward image is what? Virtual image. Where we can see that virtual image? On the surface of a lens. It is magnified. Size of image is greater than size of the object. So these are the observations. Then note down the distance. Where do you see? To find out this distance, we have one more method. That method here I'm not showing you. Just I'm giving the value on the lens, right? So I'm not giving that value also. Then we'll go for another position, right? Another position, that is placing the object at 70 centimeters, right? Placing the object at 70 centimeters. Where do you get the image? That you need to note down, right? The distance you need to measure. Okay, how to conduct this activity? Like this, you are conducting the activity. Clear, everyone? How to conduct this activity? Any confusion is there? Did you see that characteristics of image? What we noticed with the ray diagrams? With the ray diagrams. For example, here I have one of the situation, object placed at 20 centimeters. And also I'm given the table, right? Also given the table, object distance, image distance values. Object distance to image distance values are given here. Then can anybody tell me what is the focal length of the lens? Non-focal length only taken, but here I am not mentioned particularly that focal length. Can anybody answer me what is the focal length of the lens here? Did you see object distance is equal to image distance in the table in any situation?
Yes, sir.
Where?
At 60 centimeters.
At 60 centimeters, right? In your ray diagrams, any position given that object distance, image distance same? in your ray diagrams, convex lens ray diagrams. Yes, you obtained real image with same size at same distance on opposite side. That is what? At C2. Object at C1. So what about radius of curvature of given lens? Radius of curvature of given lens. It is 60 centimeters. Are you following me? How I got radius of curvature of this lens? By using the ray diagrams, what we practiced. So image obtained at same distance for the object position at center of curvature. So center of curvature to the pole distance is radius of curvature. So that I used it in this case logically. Right? Then R equal to 60. Then what about F equal to R by 2? Right? Then R is 60 by 2. That equal to what? 30 centimeters. 30 centimeters is here focal length. So I got F equal to, if I place the object, where will be the image? Ray diagrams. If you place object at infinity, image brought to the focus. If you get that image to the focus, image will be sent to the infinity. So did you see that characteristics here? Is it clear? The same ray diagrams, what we drawn, that are practically verified. Everyone, just give me your quick reaction. Practically, we have seen that ray diagram characteristics. Yes. So if any values are given, object distance, image distance, find out. Object distance, image distance, same means object is placed at radius of curvature, nothing but at C2. Okay. Or if focal length is given or object distance given something x, then image distance is given something infinity. What will be its focal length in this case? What is the focal length in this case? F equal to same x only. If you place the object at focus, the image will be obtained at infinity. Are you following? Is it clear? How I'm finding that image distance or the focal length? Based on the position only. If you place the object at infinity distance, image at focus. If you place the object at focus, image will be at infinity in case of double convex lens. Concave lens always with the fixed characteristics, virtually diminished, erect between P and F. Right? So using that logics. Then after this, we have a derivation. That is lens formula. What is lens formula? Derivation. So lens formula. What is lens formula here? Right? So before that, we are considering one imaginary situation. We are considering one imaginary situation that the object is placed in front of a convex lens, right? Having the focal length unknown, F, right? Focal length I am not giving, it is as unknown. At somewhere the object is placed. I am not saying it is maybe beyond the center of curvature or at center of curvature or in between F and C. Nothing is taken. Just it is placed on the principal axis beyond its focus. Then, can anybody draw this ray diagram? How to draw? How to draw this? Simply considering the situations, right? Parallel to the principal axis and passing through the optic center. So from the top of the object, consider two rays. One is parallel to the principal axis. After refraction, it passes through the focus. We know that. Then a ray passing through optic center, it remains undeviated. So complete that first undeviated ray. Okay. Then what about that light ray incident at a point P dash? It is parallel to the principal axis. So from this point of instance, just you are connecting a F1 with the scale, then completing the refracted light ray path. It passes through F1. Extend this to meet another refracted light ray. So where they are going to meet each other or coincide each other, that point is image point, right? O dash image is obtained as I dash. What about O point image? That will be obtained on the principal axis. Get it by constructing a perpendicular onto the principal axis as you see here. Then this is I. Is it clear, this diagram, everyone? Clear about this diagram? Right. So here, can you find similar triangles in this? Can you find similar triangles in this? So here, before going that, I'm showing you the distances here. What the distance is shown here? What the distance is given by me? Pole to the object. Object distance denoted by U. Then pole to the image or pole to the focus, right? So here pole to the image is image distance and pole to the focus is focal length. So these are the parameters I know. What? U, V, F. Then I am trying to obtain a relation between U, V, F. Between U, V, F. So that relation only here called as lens formula, right? Here, the direction I am given you with the black colored arrow, it is incident light ray direction. That parameters are taken to be positive. Then if you measure that parameters, another direction, left side, that we will take it as negative direction, right? So here I taken the diagram here, then find the similar triangles first by noticing the known parameters. Pole to the object is object distance, pole to the image is image distance, and pole to the focus is focal length. I know them. Then here, what are similar triangles you find in this diagram? Exactly with the opposite angles, right? One condition I am applying here, opposite angles are equal. Opposite angles are equal in a right angular triangle. In a right angular triangle. How many right angular triangles are there? How many right angular triangles are there?
Sir, two, sir.
Only two right angular triangles. Look at them. O dash P is right angular triangle or not?
Yes, sir.
O dash P. Then P dash O dash. Right angular triangle or not? Here the right angle is at this point. Look at. Then I have right angle here also. That is what? P dash F1. Then one more right angle triangle is available. I dash P. How many are there?
Sir, four.
4. But I applied one condition. Select the right angle triangles with opposite angles are equal. Right? Opposite angles are equal. So here among these 4 right angle triangles, I am finding opposite angles. So this angle is equal to this angle. So what the triangles are here? O dash P is similar to triangle I dash P. Is it clear how I am selecting? Then one more similar triangle is there with opposite angles. This triangle is similar to this one. What the triangles are here? P dash F1 is similar to triangle I dash F1. Clear, everyone? Are you clear with this? Yes. Right. Now we'll go for another. So similar triangles I know from the table. So note down that similar triangles here. Triangle P dash F1 is similar to triangle F1 I dash. So any direction you can follow for naming the triangles, right? Then they are similar. What we know, see here, I'm shading that similar triangles also to identify them easily in the diagram, right? Then look at that relation between them. Triangles ratios, right? Corresponding sides ratios are same here. What is PP dash? PP dash is vertical height. That vertical height in the opposite triangle is I dash is equal to basis P(F1) is similar to IF1 or F1I. Anything you can write. Are you clear about this equation? So from this, I am writing F1I by I dash. Sorry, F1 I is equals to PI. F1 I is equals to PI minus PF1. Are you clear? Why I am taken F1I equal to? Because it is unknown value. Does it have anything? No. I know up to this point. I know up to this distance. Is V. Clear? At the bottom you can see them. I know P2 I1, I know P2 F1, but I don't know F1I. So from known values, I am finding unknown value. So for that purpose, F1I equal to, I am written this total distance, right? This total distance, what you see here, black color, then you are subtracting this part, right? So here PI1 equal to PF1 plus F1I. Total length is divided into two parts, PF1 and F1I. So I am taking PI dash is equal to PF1 plus F1I. From that, F1I equal to, I am written PI minus PF1. Is it clear or any confusion? See the diagram carefully, right? If you want, I will write here PI dash is equal to PF1 plus F1I. So from this, I want F1, then it is transposed to opposite side. So on transposing, it is, sorry, PI, it is PI minus PF1 written. Clear? Now it is clear how I got PF1 like this. Okay, then go for the next point here. Another one here, PP dash by I dash is equal to, what is PF1? Focal length. We know that. So no need to change that. F1I, I don't know. So that I am substituting here, PI minus PF1. So here I got a relation by using similar triangles PP dash F1 and F1 I dash. Then I am using another combination of similar triangles. That is here simply O dash P is similar to triangle PI dash. Look at that shading. O dash P is similar to triangle PI dash. Right? Then following the same steps as we used in case of first set. Right? So writing the relation O dash by I dash is equal to PO by PI. Then here, what you know, O dash. O dash.
Object height.
Object height. Okay. Or this is the parallel lines distance or not? O dash is height, parallel lines distance. Yes. So what about here PP dash? It is also parallel lines distance. So here what I am trying to say, O dash is equal to what? PP dash or not? O dash equal to PP dash or not? So here I am replacing that O dash by PP dash, right? So here O dash equal to PP dash, then substitute in the above relation what you got. So O dash written as PP dash by I dash equal to PO by PI. So pole to the object, pole to the image, that we know. So no need to change anything, right? So now here observe the relations here. I don't want that diagram, so that's a removed. Then here minimize it. Okay, now look at that. Here two relations I obtained, where here one relation is there, here one relation is there. So in the both left side I have same PP dash by I dash. So what we can write right side? Same. So left side LHSs are equal in two equations, automatically RHSs will be taken as equal. So using that mathematical logic, then writing PO by PI is equals to PF1 by PP dash by I dash. So here from this PP dash by I dash equal to, I know PF1 by PI minus PF1. Is it clear, everyone? Is it clear, everyone? Any confusion? Nothing. Then now writing the reciprocal for this. If you write reciprocal, what we can write? PI by PO equal to PI minus PF1 by PF1. Is it clear, this step? Then we'll go for next step, if it is clear. Reciprocal written for this relation is like this. So any confusion? Any confusion? No confusion. Okay. Then go for next step here. Next step is splitting a common denominator on right side. So PI by PO is equals to PI by PF1 minus PF1 by PF1. Is it clear? Is it clear? Common denominator individually splitting this one, right? If you take LCM, we will go back to the same step, right? So that I followed here. After this, next step is cancelling. PF1 cancelled. That equal to what we'll write? PI by PF1 minus 1 remains. This remains. Then what to do? Here, I'm taking this PI towards right side, transposing towards right side. So what will be left on LHS side? It is 1 by PO. It is 1 by PO remains. So here, PI taken common, PO left on LHS side. Then RHS side, take PI common again. Then what will be remains? It is 1 by PO, 1 by PO minus 1 by PI. If you expand, PI gets cancelled, and second term on right side remains as 1, right? So here I got this one. Then on both sides, PI gets cancelled. The remaining is 1 by PO is equals to 1 by PF1 minus 1 by PI given. Everyone clear up to here? Just I depended only on the similar triangles concept here, right? For curved surfaces, exterior angles concept. For lenses, similar triangles concept. Okay, then 1 by PO is equals to what? 1 by PF1 equal to, because I'm giving you a relation to find out focal length. So this F1 is taken as LHS, then remaining will be transferred to another side. So here what I will write, 1 by PF1 equal to 1 by PO plus 1 by PI. Just transposed it. Then here apply the rules of sign convention. Right? Apply the rules of sign convention. So here rules of sign convention, in the direction of incident light ray, it is positive direction. Opposite side to the incident light ray direction is taken to be negative. So this is positive direction. This is negative direction, right? So who is at negative direction side? U, object distance. Then image distance towards positive side. Focal length towards positive side. Then apply the rules of sign convention here. Okay, so object distance is negative. PO is equal to minus U. Image distance PI equal to V, positive. Then focal length PF1 equal to positive. Then substitute that values in the above relation. 1 by PF1, that is positive. So replace it by F now. That is equals to 1 by PO. PO is object distance. It is negative symbol. So minus U substituted. Plus 1 by PI. PI is according to sign convention positive. Substitute. That's substituted. So what I got here, minus 1 by U and plus 1 by V. Negative term second, positive term first. So 1 by F is equal to 1 by V minus 1 by U. So this is here called as lens formula. Right? That is we are calling as lens formula. Is it clear how to derive this equation? Just using any one situation to obtain a ray diagram. After that, just using similar triangles concept, nothing I did. Is it clear? Individually. Vikrant? Clear? Right? So practice once, because we don't know how they are going to ask